Hello everybody and welcome to a new video. In this video we will be solving more problems on Coulomb's law. This time let's see what will happen if these charges are not aligned. In other words, let's look at this configuration of charges. Find the net force on charge number 3. Where is charge number 3? We can see that charge number 3 is this charge. It's on the upper corner. This is charge number 3, okay? So if we draw the free body diagram, we draw a quick free body diagram, we see that this is charge number 3. The relationship between charge number 1 and charge number 3 as they are different from each other, so it will be attracted towards this charge. We will call it force, the effect of 1 on 3, and we know that these charges are different, so it will repel. It will go in this direction in a force that we will call F23. Okay, so we will need to find F13 and F23, and then the final force, the summation of forces, we will use the Pythagorean theorem. It will be F23 squared plus F13 squared. Okay, so first of all, let's find F13. F13, we know that F13 Coulomb's constant multiplied by Q1 multiplied by Q3 divided by R squared. It's pretty straightforward right now. So 9 multiplied by 10 to the power 9 multiplied by charge number 1 is equal to 12. Sorry, it's 9 multiplied by 10 to the power negative 6 multiplied by charge number 3, which is 12 multiplied by 10 to the power negative 6 divided by the distance. Actually, the distance here is in 20 centimeters, so it's equal to 0.2 meters. And here, so we don't forget, it's 0.1 meters. So we will say by 0.2 squared, and the answer is 24.3 newtons. The same thing is for F23. It's going to be equal to Coulomb's constant, which is 9 multiplied by 10 to the power 9 multiplied by the charge of Q3, which is 12 multiplied by 10 to the power negative 6 multiplied by the other force, or the other charge, sorry, which is equal to 5 multiplied by 10 to the power negative 6, and this time the distance is equal to 0.1 squared. So this gives us an answer of 54 newtons. So summation of forces is going to be equal to square root of 24.3 squared plus 54 squared. This will give us the answer of 59.2 newtons. But the direction, it will be in this direction. So this is the net force. Okay, so the final answer is 59.2 newton. 2-point charges Q1 and Q2 are separated by a distance r. If the sign of Q1 was changed, the electrical force on Q1 due to Q2 will be, what do you think will happen? Okay, sometimes when you're asked these type of questions, always keep the equation in front of you. We know that the force between them is going to be equal to the constant of Coulomb multiplied by Q1 multiplied by Q2 divided by R squared. So it's saying here that the sign of Q1 changed. So imagine if it was positive, then it became negative. What will happen to the force between them? Okay, so let's go back to the parameters here. Did Coulomb's constant change? No, it's constant. Did the charge change? Well, the charge changed its sign, but its value did not change. So Q1 is the same value, and Q2 is the same value, and the distance is the same. So this means that nothing will happen to the force. Even if we didn't read the options yet, we see that we have, it will be quadruple, it will be double, it will be the same, it will be half. The answer will be the same because nothing changed, only the sign. And we said that the sign does not affect the amount of force. It affects the direction of the force, but it does not affect the amount of the force. So it was a little bit tricky. What will happen to the magnitude of force on Q1 if it was doubled while Q2 remained the same? So now this time, let's look back on our equation. Instead of Q1, it's going to be 2Q1, right? So we will replace Q1 with 2Q1. So the equation will be like this. The electrical force F is equal to Coulomb's constant multiplied by 2Q1 multiplied by Q2 divided by R squared. So what changed here? What changed is that the total final value, we can just rearrange it. It will look like this. F is equal to 2 multiplied by QC multiplied by Q1 multiplied by Q2 divided by R squared, right? So what happened here is that the force will be doubled. Okay, so in this time, the answer will be the force will be doubled. So it's clear here that the force is doubled.